Let's keep going with the metadata. Last time we set up the metadata objects to be created. So we have this little thing down here telling us how many metadata objects exist, and they will persist as long as the item slots that they are assigned to persist. But we had the issue that if we split these stacks and we check the metadata again, it's 7 objects because I picked up 2 other objects. That's a bad example. But if I check it again, it's still 7 objects because what it's doing is both of these stacks are just referring to the same metadata object. The newly created stack isn't getting its own metadata object, which means that even if I were to remove this one would still have a metadata object, but then if somehow the metadata on this one would change, the metadata on this one also changes, which obviously is not exactly what we want. And that is because that is how references work. Because if we have an inventory slot, it has a reference to an object that like physically exists somewhere, not physically in the world, it's not an actor, but we have like this object. And if we split the stack, it's just creating another pointer to that same object. And what we want to have happen is when we split a stack, what it should do instead is it should create a new object that is identical to the one that we have and point to that one instead. Similarly, we can still merge items even though we're not checking if the metadata between the 2 stacks matches either, which is obviously also an issue. So let's take care of the splitting stacks first, and then we'll go into the merging stacks a little bit after that. We'll go into my blueprints folder here, and I'm going to go into my BPI inventory utils, and I'm going to be adding a new function to this. And this will be copy metadata. And for that, we will take one input parameter, and that will be the metadata object in, which will be a BP metadata. And then we'll also make a metadata output, which will be the metadata object out. And this will be the copy. Now, for every single metadata class that we're going to be making, we need to make an implementation for this, because every single metadata object is going to have different data. So it's going to have different data that it needs to copy over into a new object. That's just kind of the reality of how this is going to work. Actually, now that I'm thinking about it, we don't need the in metadata, because that's just going to be the object that we're implementing this on. So we only need to have the metadata object, let's call it copy instead. Let's go into our BP metadata object, like the parent one that we have over here. And if we go into the class settings, we can say the implemented interfaces, we add one into those, and we'll add in our BPI inventory utils. And if we open this up, we can see the copy metadata. And all that we need to do here really is construct object from class. And in this case, what we can simply do is we can just construct a object of BP metadata. We don't need this to be like dynamic or anything like that. For the outer, we will want to get player character, but we can't do that because, again, this is just a generic object. This is not an actor. It doesn't have access to a bunch of different functions. So what we'll do instead is we'll go back into the inventory utils, and we will make an input here after all. And this will just be we can make this an actor type. Let's just to be sure, so that everything always is going to be the third-person character. Player character outer, I'll call it, so that it's clear what we're using it for as well. And that way we can just pull that through. Now, every time we try to copy over some metadata, we do need to provide the player character, but we simply just cannot get the player character from inside here very easily. So that's the way that we go around that. Now that we have this new constructed metadata object, we can set the counter value in it to the counter value of this object. And then if you have other information in here as well, like strings or enums or floats or whatever, you just simply do this for every single value that exists on your metadata object. And once that is done, we just supply that in this. And now we have a function that copies over your metadata object. Now, with this, if you really want to make something that has the outer of your metadata object being the inventory component, rather than it being the player character always, this would also be the way you can do that. You can just make this a normal object input pin, and then you can put in whatever outer you want. And that way you can just copy over into a new metadata object that has a new outer, which might be worth doing. So let's go back into this and just make this a normal object reference anyway. That way it is more flexible to do what you want with it anyway, if you want to do other stuff with it. So funny story, I just recorded a segment updating the split stack function here. Apparently we don't even use the split stack function anymore, like at all. So we can just kind of remove that, and that will prevent any confusion in the future. So the way we apparently do it is in just the item slots on mouse preview key down. This bottom branch is just like all that. So we're going to be doing it in here. So when we make this new item drag preview, instead of taking in the metadata from the inventory slot itself, it's going to be copying over that metadata. So we copy metadata with the message, and we put that after the setting of the inventory slots. We get player just to have that context object, and that is then going to be our new metadata object. And that's really all there is to it. Just adding in that one new function is going to make us a copied metadata object. And now we'll be able to see if we go into our list, we have 5 objects. This should be 6, 7, 8, and 9. And now we have 9 metadata objects. So it's creating new objects. If I try to garbage collect, it still has 9 objects because the inventory slots are actually referring to new metadata objects there as well. So it's saved from garbage collection, and we now have actually copied over metadata, which again, we can now in theory use if we wanted to make the outer of every single metadata object refer to the inventory component that they're on. Now, when you transfer them to a new inventory component, we can detect that and copy over the metadata, give it a new outer. If that is relevant to your specific game for whatever reason, for maybe performance reasons, especially if you're doing something multiplayer related, I can imagine that being a thing. That's something you can do. I think just assigning everything to the player character is easy and usually more than stable enough. That brings us to the second half of this metadata thing, and that is merging the stacks. So for that, let's go back into our inventory utilities and make another function here. And this is going to be taking in one input for the metadata to compare, which will obviously be a BP metadata. And then it's going to be outputting a R equal value for a bool. And much like before, once we have made that a function here, let's give it a name actually, compare metadata. And we go back into our metadata. We now have this compare metadata function. And here we can do something actually quite similar to copying the metadata. First and foremost, we would need to cast this to another metadata class if we are doing this with a child metadata class. So if we have like sort metadata, we would cast to sort metadata and then get it out of there. But since this is just the base metadata class, we can just simply get counter from this and then get counter from this. So that's just this counter value over here. And we'll just check, is this equal? And we'll just simply return that. Now, if you have multiple values to check, you just want to check a AND boolean with a bunch of different pins and see if they're all equal. And if you have a cast to BP metadata, for instance, and you do that, you would also add in a return node here where R equal is false. Because if they're not the same class of metadata to begin with, they're definitely not going to have the same actual metadata inside. But for this simple class, we don't even need that. And this is the simplest way to check that. So implementing that in our item slot stuff here, which this function specifically probably needs to be collapsed into a couple of different other functions and stuff like that. I'll probably make one big cleanup video just so that everybody is aware of what I've changed in the eventual project files for the patrons and stuff like that. But somewhere in here we have merge stacks, and there we are just going to check, hey, both of these, before we do anything else, I'm going to take the source metadata or the target one, it doesn't really matter. And we're going to compare metadata, and we're going to compare that to the other one. Because if these two are not equal to begin with, there's no point in doing any of the other calculations, because we're not going to be merging these things together anyway. And we need to give like a feedback value as to this being unable to merge. So we'll put in a return value here. And we haven't had return values here up until this point, but we will need to do that now. So let's add in a was merged, capital M, just so that it makes it separate words. And it was not merged if we do any of this. But if we do this stuff, it was merged. Let's see, do we actually do anything with that in the item slots, like afterwards? So if nothing here was merged, what we want to do is we put in a branch for that and we don't do anything. So we only do the rest of this code if a merge actually happened. And we'll make sure that we like return here with a was merged true. Now we need to make a way to differentiate between the different metadata on different stacks, which is something that I wanted to show you anyway. So I had that counter value on the metadata object just because it's easy to like count how many times something has been clicked. So let's go into the item slots here. So when we click on one of these, let's see, on mouse preview button down, what we'll just do is we will get the inventory slots, we will split the structure pin, we'll get the metadata, and we'll get the counter, and we'll just simply increment this counter for just debug purposes. Obviously, this is not going to serve any actual gameplay reason, but it'll show us nicely. And now that we're at it anyway, let's also print string. This might crash when we press on a thing that doesn't have an item in it. It just gives you some errors. But as you can see, when I click on this one a couple of times in a row, you can see it starts counting up every time I click on it because it's got that metadata. But then these ones, of course, have their own independent metadata. And if I split these, it will copy over that metadata. So this will now keep counting 5, 6, 7. And this will now keep counting as well. 5, 6, 7. Now that it becomes 8, I can still merge them together because clicking on it technically increase the other one to 8 as well. So let's split these apart as well and click on these a couple of times. So now they're definitely not the same value and it will not allow me to merge them anymore until I've clicked on it enough to the point where they are back at the same metadata value. So our splitting of stacks with the metadata and our merging of stacks only if they have the same metadata now works as well, which is quite an important piece to this whole thing. Now I think we want to dedicate a separate video, which is going to be a shorter video, to having child classes of the metadata object and implementing those. So maybe next time we'll make a metadata object for the sword so that we can have like enchantments for the sword. For now though, we're back into a functional system where we can start adding new features, and adding new features is always more fun than fixing up things that your previous new features have created. That's just what programming is, man. It's just get used to it. And for the full course, if you're watching this in the future, it should be all up on the YouTube channel already. But if you're watching this shortly after it was uploaded, there will be a link down below in the description to the Patreon where you can find the full course. And a very big thank you to all of my Patreons. You can see them on screen right now. If you want to help out supporting the channel, there's a link down below in the description to the Patreon page. A huge thank you to my Cave Student tier supporters, Earl Monseval Erno, and my Cave Digger tier supporters, Sergey Thomas,